Mathematics is often seen as a purely logical and abstract discipline, but its philosophical foundations go back to ancient times. Philosophers have long debated whether numbers are real, abstract, or merely tools of human thought. In this video, we will explore how numbers were understood by four major philosophical traditions: the Pythagoreans, Plato, Aristotle, and the Neoplatonists. Pythagoras believed that numbers were the fundamental building blocks of the universe. They saw mathematics not as mere tool, but the essence of reality itself. One of their most famous contributions is the Pythagorean theorem, which states that in a right-angled triangle, the square of hypotenuse is equal to the sum of squares of the other two sides. This theorem became a cornerstone of geometry and has countless applications in mathematics, physics, engineering, and even computer science today. For the Pythagoreans, numbers were mystical and even had moral qualities. Odd numbers were seen as male, even numbers as female. Their ideas laid the groundwork for later mathematical and philosophical thought. Few individuals have influenced the world and many of today's thinkers like Plato.
One 20th century philosopher even went so far as to describe all of Western philosophy as a series of footnotes to Plato. He created the first Western university and was teacher to ancient Greece Critics minds, including Aristotle. But even one of the founders of philosophy wasn't perfect. Along with his great ideas, Plato had a few haven't exactly stood the test of time. So here are brief rundowns of a few of his best and worst ideas. Plato argued that beyond our imperfect world was a perfect unchanging world of forms. Forms are the ideal version of the things and concepts we see around us. They serve as a sort of instruction manual to our own world. Floating around the world of forms is the ideal tree and the ideal thing like YouTube, and even the ideal justice or ideal love. Our own reality is comprised of imperfect copies of ideal forms. Plato gave the leaders and thinkers who came after him a place to start. Through the centuries we have the chance to test those ideas through writing and experience, and have accepted so while rejecting others. We are continuing to refine, amend, and edit his ideas which have become foundation of the modern world. Aristotle, Plato's students, strongly disagree with the idea that numbers exist in a separate realm of ideal forms. Instead, he argued that numbers and mathematical concepts are abstractions derived from the real physical world. And that is how Neoplatonism was created. Plato would answer Aristotle, "You see only the surface of things. Consider the nature of a circle. No physical circle in the world is perfectly round yet. We recognize the perfect circle in our minds. How can this be? If not for the existence of ideal form, a perfect circle is real beyond our sense."
Aristotle, however, would say, "Plato, I respect your wisdom, but I believe our understanding of a circle comes from repeated observations of various round objects. It's our abstraction from the physical world, not a glimpse into separate reality. Mathematics is a tool we invent to describe the patterns we observe, not the discovery of pre-existing truths. While the dialogue is fictional, it captures the essence of philosophical difference between Plato and Aristotle. Regarding the nature of mathematics, there are arguments that support both the idea that mathematics was invented and that it was discovered. Philosophers who support the idea of invention argue that different cultures have developed their own mathematical systems, demonstrating that mathematics is influenced by human invention. For example, Roman numerals, the Mayan number system, and the Babylonian-based 60 system are all different ways of representing numbers, showing the human-created nature of the mathematical symbols. Many mathematical concepts, such as numbers or infinite sets, do not have direct physical counterparts and are abstract in nature. These abstract concepts are the products of the human imagination and creativity, indicating that mathematics is an invention. Certainly, there are arguments and perspectives that support the idea that mathematics was discovered rather than invented. Mathematical truths and relationships appear to be universal and consistent across cultures and civilizations. The Pythagorean theorem holds true regardless of cultural and historical context. The consistency of mathematical principles suggests that these truths were not invented but discovered. Mathematics plays a fundamental role in scientific theories and explanations. Scientists often use mathematical models to describe the behavior of physical systems and make predictions. The success of mathematics in explaining and predicting natural phenomena suggests that it reflects inherent properties of the universe, supporting the idea of discovery. Ancient Greeks have provided scientists, economists, lawyers, architects, and well, just about everyone with a new mathematical understanding of our world. Thank you for your attention and hope you enjoyed our video.